Now we are going to explore the characteristics of sine and cosine functions and identify what similarities they have with waves in physics. The main characteristics of sine and cosine waves are amplitude, period, phase shift, and vertical shift. As you can see, the general form for a sine or cosine function is y equals a sine parentheses bx minus c in parentheses plus k, where a stands for the amplitude, and k is a constant that defines the vertical shift of the graph. If b and c are present in the function, then there will be a phase shift as well as a change in period. To determine the phase shift, divide C by B. Usually the graphs of sine and cosine functions start at the y-axis and have a period of 2 pi. To find the change of period, take one cycle, 2 pi, and divide this by B. When graphing, first determine what is going on with the equation. Do you have an amplitude? Is the period going to change? Will there be either a phase shift or a vertical shift, or possibly both? Now draw the basic pattern of either sine or cosine function. In this case, we will draw a sine function. Label your graph accordingly to the period and perform any shifts necessary. Now let's take a look at a few examples. Let's take a look at the equation y equals 3 sine x. Notice how this is a variation of the general form we saw recently. We're going to see that the amplitude here is given by a, which is 3 in this equation. In this equation, we can also see that the period is given by using the cycle 2 pi over b. But in this case, b is equal to 1. And therefore, our period remains 2 pi. Next, we're going to take a look at the phase shift. And in the general form, this is given by c. However, in this instance, we don't have a c, and so therefore the phase shift is 0. And referring back to the general form, k gives us the vertical shift, and in this instance k is 0, therefore our vertical shift is 0. Now we're going to sketch the graph, but first, in comparison, we're going to sketch the graph of sine of x. Here we use the period of 2 pi. Notice how the amplitude for the sine of x graph is 1 above the x-axis and -1 below the x-axis. Now we're going to draw the graph 3 sine x, and here we'll start off by putting 3 above the x-axis and -3 below the x-axis to identify our amplitude for this graph. Here we're going to put the intervals, which is 2 pi, half of that is pi, half of pi is pi over 2, and if you add pi over 2 plus pi, you'll get 3 pi over 2. Now let's take a look at another equation. Here we have y equals cosine x plus pi over 2 minus 2. Here we notice that the amplitude is 1. Now we see that the period given by 2 pi divided by b, where b is 1, is just 2 pi. Now we take a look at the phase shift. Here we see a difference from the one we had last problem. Here c is given by pi over 2. Now pay close attention here, as the phase shift is not going to be positive pi over 2, it's actually going to be negative pi over 2. And of course we divide c by b, and b is 1, so our phase shift is going to be negative pi over 2. Now we look at the vertical shift. Here we notice we actually do have a k in this problem, and k is given by negative 2. Therefore, the vertical shift will be 2 units down. Now we're going to sketch the graph. But in order to really give you guys a visual of what's going on with the phase shift and the vertical shift, we're going to first draw the graph cosine x. Remember that cosine x on the y-axis starts at 1. Notice how it also has an amplitude of 1 above the x-axis and negative 1 below the x-axis. And we keep the same cycle or period. 2 pi, half of that is pi over 2, and of course 3 pi over 2. Next we're going to draw the same graph, but we're going to include the phase shift. Notice how the phase shift is negative pi over 2. Here we're actually going to go to the negative part of the x-axis. We're moving the graph over pi over 2 to the left. So now that we have our points set up, let's connect the dots. As you can see, it's basically the same graph as cosine x, just shifted to the left. Now we're going to take a look at when the graph utilizes the vertical shift. So we're going to keep the same graph with the phase shift, but now we're going to just drop it 2 units. Here you can see that it's basically the same graph as the previous two. The only difference is that we included the phase shift and the vertical shift on this graph.